I am of the opinion, question 3, which says if the measure of an angle theta is 5 pi over 4, which statement is true? When you're first learning this, it is helpful to convert this to a more familiar set, value set, which would be degrees. So this is in radian mode. So we're going to convert this to degree mode. And to do that, we're going to take the radian measure. And this should be a familiar formula you're familiar with. We're just going to multiply that radian measure by 180 divided by pi. The pi's will cancel. 5 times 180 is 500, 900 divided by 4. And then let's get our calculator out and take 900 and divide it by 4. So we get 225 degrees. So that we're more familiar with. It's not quite a full circle. So if we graph that on the coordinate plane, remember each one of these quadrants represents 90, and we go counterclockwise, so that much is 90. This much is another 90, so it's 90 plus 90 is 180. And then so 180 minus 225 is 45. So we need to know, we know this angle is going to go an extra 45 degrees. So the angle that we're looking at, let me change colors. The actual angle that we're looking at is this angle right here in quadrant number 3. So right off the bat, I can see what the reference angle for this problem is going to be. The reference angle is always acute. It's always the angle that's formed with the x-axis. So that's our 45 degree angle is our reference angle. So we know it's not 30 and we know it's not 60. So we could find the other answer using a graphing calculator, but I'm going to do this the long way just to show you an alternate way to do it other than just with the calculator. So I'm going to take that triangle right here. I'm going to take that triangle right there and draw it up here just so it's got a little more space to work. That's a 45 degree angle. That's my 90 degree angle, and that's 45. So remember with the unit circle, the length of the radius, which is this length right here, we can assume it's 1. So to be able to find sine, cosine, and tangent, and let me do this in a different color as well, that 45 degree angle is really the one we're looking at. That's our reference angle right here. So to figure out sine, cosine, and tangent of that reference angle 45 degrees, we need to find the missing sides. We need to find this side and we need to find this side. The good thing about this, since it's a 45, 90 degree triangle, we know that x and y are going to be equivalent. So we can use Pythagorean theorem, a squared plus b squared equals c squared. We know the hypotenuse is just 1. And we know that a and b are the same. So we'll just call them both a. So a squared plus a squared is 2a squared. 1 squared is 1. Divide both sides by 2. We get a squared equals 1 over 2. Take the square root of both sides, and we're going to get a equals plus or minus. Square root of 1 is 1. The square root of 2. Can't take the square root of that, but recall you cannot have a radical in the denominator, so we're going to rationalize that denominator. And all that work, we're going to end up with this. So this is the square root of 2 over 2. And so is this. But we got to be careful here. Because remember, we're in the third quadrant. And what do we know about the x and the y coordinates in the third quadrant? They're both negative. So both of those are negative radical 2 over 2. So now finally, I'm going to erase all this work to give myself a little more space. But finally, we are ready to find the cosine of this 45-degree angle. Ready to find cosine, we're ready to find sine, we're ready to find tangent. So the cosine of 45, remember, is adjacent over hypotenuse. The adjacent side is negative square root of 2 over 2 divided by 1. Anything divided by 1 is itself. So we get negative radical 2 over 2. Not that one. The sine of 45, opposite over hypotenuse, is going to be the same thing because the opposite side is also negative radical 2 over 2 divided by 1. And we get negative radical 2 over 2, not positive. So we cross that one out. And then finally, tangent of 45 is opposite over adjacent. So that's just negative radical 2 over 2 divided by itself. Anything divided by itself is 1. So we can also check this one off. Did we have to go through all that process? No. You could have used a graphing calculator and you could have taken the sine, cosine, and tangent of that 225-degree angle and got this answer. You could have also used common sense. You know cosine and sine are both negative when we're in quadrant 3. So once we saw those angles were in quadrant 3, we knew it couldn't be sine and it couldn't be cosine. And since this is one of those select all that apply, you could probably make a pretty educated guess that tangent of theta was equal to a positive 1. But again, also use the graphing calculator.